Hello students, I am Sir Montesor Lumagbas, your science teacher, and today we will be talking about describing a mixture. Are you familiar with mixture? If not, don't you worry because we will be talking about mixture for the whole grading. So now, let's get started. Let's take a look at this example. So what do you see on the picture? Yes, it is the very common Filipino called dessert, which is halo-halo. How is this cold dessert made? Yes, by mixing all the ingredients, correct. Then, what are the ingredients in making this dessert? Very good. You need ice cream, leche flan, fruits, sago, milk, ice, and many more. Now, do you think we can easily separate the ingredients in making halo-halo? Of course, we can actually separate the ingredients in halo-halo since the ingredients are big enough and not all can be dissolved in water. Next, do you think halo-halo is a mixture? Yes or no? Okay, if you are not sure, don't you worry because we will find out later if a halo-halo is really a mixture. Okay, so now let's talk about mixture. In science, when we say mixture, it is a combination of two or more substances that are not chemically combined, meaning you mix one substance into another substance, forming a mixture as long as they are not chemically combined. When we say not chemically combined, meaning the individual property of a substance still remains. Example, when you make a coffee, you mix coffee in a water, but still, the taste of the coffee is still there, and the taste of the water is still there. They are not lost. Another example is when you mix a salt water. So salt mixed with water, still you taste salt and you taste the water. That is what we call mixture, meaning they are not chemically combined because the individual property of each component still remains. So, when can we say that a substance or a thing is a mixture? Of course, when components are not chemically combined, that's what I have talked about earlier, that components are not chemically combined, meaning they can be easily separated. Properties of the component still present, meaning uh, one component like sugar still remains, though even though it is mixed in water. Next, the ratio of components may vary. For example, when you make a coffee, so the components like the ratio of coffee is different from the ratio of or the amount of water. And of course, components can be easily separated or can be physically separated. When we say physically separated, we can just use spoon or cup in order to separate the individual ingredients in making a mixture. So now, let's try to answer the following activities. So let's try to identify if it is whether it is a mixture or not. Pizza. Yes, of course. Definitely it is a mixture because it is a combination of flour, sauce, cheese, and many more. Porridge. Of course, it is a mixture. It is a combination of rice, chicken, spices. Ding dong. Of course, mixture. Water. Water is definitely not a mixture. Rather, it is what we call a substance. Meaning, water itself, it cannot be separated physically. Okay, unlike pizza, ding dong, and porridge, in which uh, components can be easily separated. Milk. Of course, it is a mixture of milk and water, so it is a mixture. Okay, so now let's proceed to the types of mixture. So there are main two types of mixture: the homogeneous mixture and the heterogeneous mixture. So let's try to differentiate the characteristics of a homo and a heterogeneous mixture. First, when we say homogeneous mixture, components are not recognizable and evenly mixed. So from the word itself, homo, meaning uniform or same in appearance. So you cannot really identify what substance is being added to another substance because it is evenly mixed. Good example of that are the vinegar and soy sauce. So when you mix vinegar in a soy sauce, you cannot identify which part is the vinegar and which part is the soy sauce because they are evenly mixed. Another is the sugar and water. Since sugar is thoroughly dissolved in water, so you cannot identify uh, which part of that mixture is sugar and which part of that is uh, which part of that is the sugar. However, you know that there is sugar in there because it tastes sweet. Another is salt and water. You know that there is salt in water because it tastes sour. I mean salty. Next is water and alcohol. However, on the other side, when we say heterogeneous mixture, components are recognizable and its faces are visible. So this is opposite to the homogeneous, meaning hetero, meaning different, meaning you can recognize what substances are being added to another substance, and its faces are visible, meaning when you mix a solid component, meaning the solid particles are still there. You can visibly uh, see the solid particles. So when you mix a liquid substance, you can easily identify what liquid substance is being mixed. So that is what we call heterogeneous mixture. Good examples of that are marbles and pebbles. So marbles and pebbles, they are not mixed with each other. Okay, they are not evenly mixed with each other. Okay, because you could still identify the marbles and you can still identify the pebbles. Another is sand and pebbles, nuts and crackers, cooking oil and water. Since oil doesn't mix with water, oil always floats up. Then sand and water, since sand doesn't um, dissolve in water. Okay, so those are the differences between homogeneous and heterogeneous. They differ mostly on the appearance because homogeneous simply uniform in appearance, while heterogeneous non-uniform in appearance. Okay, so you have now understood the differences between a homogeneous and a heterogeneous mixture. So let's try to identify the following pictures, whether they are homo or heterogeneous mixture. First, sausawan. Correct. This is a heterogeneous mixture because you can still identify the spices. Spices or the components are not evenly dissolved. Spaghetti. Of course, it is a heterogeneous mixture. You can still identify the sauce and the pasta. A coffee. Basically, coffee is a homogeneous because you can no longer identify the coffee powder from the water because coffee powder is thoroughly mixed in the water. Soft drinks. It is a homogeneous. Uh, a soft drink or a soda is a combination of sugar, acid, and a gas. Burger. Definitely a heterogeneous mixture. Spaghetti sauce, a heterogeneous mixture. Macaroni, a heterogeneous mixture. Chocolate cake, hetero. Acetone, it is a homogeneous mixture since it is uniform in appearance. Iced tea, so iced tea alone is uh, a solution, I mean a homogeneous mixture. Since on the picture there are lemon and a tea, so it is considered a hetero. Cologne, hetero. I mean homo. Cologne, homo. Maja Blanca, hetero. And a bleach. Well, basically, a bleach is uniform in nature. However, it is called heterogeneous, and later we will find out why a bleach is called heterogeneous mixture.